Hello mathematicians, here is Unit 6 review sheet number 1, and this will look just like the test. So if you feel great on this review sheet, you will feel great on the test. Number 1, we're going to do some traditional multiplication, 68 times 23. We're going to multiply 3 times everything on the top. 3 times 8, then 3 times 6. 3 times 8 is 24. 3 times 6 is 18. Plus 2 is 20. So that takes care of the 3. Now we need to multiply the 2 by every digit on the top. But that 2 is not really a 2. That 2 is really a 20. So we need to put a 0 here, and that'll bump everything to the correct place. I'm going to cross this out since I already used it. And I'm going to do 2 times 8, then 2 times 6. So the traditional multiplication algorithm, you multiply and sort of break apart, and then it kind of puts it all back together for you at the very end. All right, 2 times 8 is 16. 2 times 6 is 12, plus 1 is 13. And of course, our last step is to add both of those products together to get our final product. $1,564 is our final answer. All right, the second one, 37 times 16. We're going to multiply 6 times each digit on the top. 6 times 7, then 6 times 3. 6 times 7 is 42. 6 times 3 is 18. 19, 20, 21, 22. Now we're going to multiply all the digits on the top by that 1, but that 1's not really a 1. A 1 in the tens place is really a 10. So we need to put a 0 there, and that'll bump everything to the correct place. 1 times 7 and 1 times 3. That's easy. 1 times 7 is 7. 1 times 3 is 3. And our last step is to add both of those products together. So we're sort of breaking the problem apart, and now we're putting it all back together for our final product of 592. So we just did 2 multiplication problems. Number 2 is a multiplication problem, but it's a word problem. Here we go. Our school is collecting coats to donate to Coats for Kids. We want to collect 500. So far, we've collected 9 bins of 25 and 16 bags of 12. How many more coats do we need to get to 500? This is like a 3-step problem. Our first step is to figure out how many coats would this be. 9 bins of 25. So imagine like 9 containers, and they each have 25 coats in them. So we're going to do 25 times 9. So this is the first step. Leave yourself some room. 25 times 9, I'm going to do 9 times 5 then. 9 times 2. 9 times 5 is 45. 9 times 2 is 18. 19, 20, 21, 22. So that's 225 coats so far. The second step is to figure out how many coats this is. 16 bags, and there's 12 coats in each bag. So imagine 16 big bags, and there's 12 coats in each bag. How many coats is that? Well, let's figure it out. 16 times 12. 2 times 6 is 12. Carry the 1. 2 times 1 is 2, plus 1 more is 3. But when you're multiplying with a double-digit number, we need some more work. Now we're going to multiply with that 1, which is really a 10, so stick a 0 there. 1 times 6 is 6, and 1 times 1 is 1. Add it all together. It's 192 coats. Gosh, I think this is a 4-step problem, actually. So that means that's how many coats we have so far. So let's add it up. Let's add how many coats we've collected so far. 225 from the bins, another 192 bags. So if we add that up, that'll be how many coats we have all together. $417. We've done so many steps, I feel like I need to read the problem again. The question is, how many more coats do we need to get to 500? So we've collected 417, but the question is, how many more do we need to get to 500? So we need to know the difference between 500 and what we've collected so far. Let me get a new color here. So let's do our goal minus what we've collected so far, and that will tell us how many more coats we need to collect. I can't do 0 minus 7. Can't take away from nothing. So I'm going to take 1 from my hundreds place. And 100 is the same as 10 tens. But I still need help in my ones column, so I'm going to take 1 of my tens, which is the same as 10 ones. Now I can subtract. 10 minus 7 is 3. 9 minus 1 is 8. And 4 minus 4 is nothing. So that means we need 83 more coats to reach our goal. So this was a 4-step problem. That's our final answer there. First we multiplied. We multiplied again. We added up to get our total of what we've collected. And then we did a subtraction problem to figure out how many more coats we needed to collect. Okay? So this problem wasn't difficult, but there were a lot of steps involved. All right, number 3, let's do 2 division problems, and then there's going to be a division word problem. So our division problem is 86 divided by 7. So I'm thinking groups of 7, groups of 7, groups of 7. You can make one group of 7 from 8. Multiply. 1 times 7 is 7. Subtract. Bring down. So I have 16 left. Can you still make some groups of 7 from 16? Yeah, you can make 2 groups of 7. 2 on the top. Multiply. 2 times 7 is 14. Subtract. There's nothing to bring down. That's when you know you're done. So our answer is 12. Remainder 2. So remember the steps of multiplication. Gosh, we've sung a lot of songs, but let's do this one. Divide, multiply, and subtract. Bring it on down and bring it on back. Divide, multiply, and subtract. Bring it on down and bring it. Very good. Okay, the second one, 355 divided by 8. So I'm thinking groups of 8, groups of 8, groups of 8. Okay, can you make a group of 8 from only 3? No, but you can make a group of 8 from 35. Some people like to put a 0 there to keep everything lined up. How many 8s can you make from 35? I'm thinking 8 times what gets me as close to 35 as possible? 8 times 4. Multiply. 8 times 4 is 32. Subtract. Bring down. Does anybody remember where kids were making the most mistakes with long division? It was on the, say it out loud, the subtraction part. That's right. So be careful as you subtract. All right, we have 35 left. Can we still make groups of 8 from 35? Yeah, we can make 4 groups of 8. Multiply. 4 times 8 is 32. Subtract. There's nothing to bring down. That's when you know you're done. 44. Remainder 3. And it's a remainder because you can't make another group of 8. All right, now let's do a division word problem. It says, Lily and her 6 cousins, so that means there's 7 people, went to the vacation. 7 kids found 217 shells and decided to split them up evenly. How many shells will each kid get? So they're dividing the shells between themselves. So let's do a division problem. 217 shells divided between 7 kids. So we're thinking groups of 7, groups of 7. You can't make a group of 7 from 2, but you can make a group of 7 from 21. 3 groups, exactly. 3 times 7 is 21. Subtract, bring down. Oh, this is going to work out perfectly, I can already tell. Can you make a group of 7 from 7? Yeah, 1 group of 7. Multiply. 1 times 7 is 7. Subtract. There's nothing to bring down. So that means that each kid It's exactly 31 shells each. If it's a word problem, it's good to label it. Okay. Number 5, find the area. Area is length times width. Multiply the length times the width, and that will give you the space inside, the area inside. So the first one, the length is 8, the width is 3. 8 times 3 is 24. When I say area, you say square area. 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 Square feet is what it needs to be labeled. It must be labeled properly. So not only will I be looking for the correct number, I'll also be looking for the correct label. Okay? And it's square feet because it's not like the length of something, it's like how much space there is, which is a different measurement. All right, and the second one, 15 times 11. I cannot do that in my head, so I'm going to do a multiplication problem. 15 times 11. Multiply that 1 times all the digits on the top. 1 times 5 is 5. 1 times 1 is 1. Is 0. Let's use that other one. 1 times 5 is 5. 1 times 1 is 1. Add them together. 165. I'm going to use the word inches. What kind of inches? When I say area, you say square area. 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 So it's got to be square inches. So we just did 2 area problems. Now let's do an area word problem. The area of the sidewalk on our street is 1,395 square feet. And one of the dimensions is 3 feet. So imagine a sidewalk. It is probably about 3 feet wide, but really long, right? So we're wondering how long is the sidewalk. So this is an area problem, but working backward. Usually to find area, it's length times width. What's the opposite of multiplying? Dividing. So for this word problem, they've given us the area. They've given us one dimension, but we need to figure out the other dimension, the other length. So the opposite of multiplying is dividing. So if they give you the area and one side, divide, and that'll tell you the length of the other side. So we're going to do 1,395. And if we divide it by 3, that'll give us the length of the sidewalk. So I'm thinking groups of 3, groups of 3. 3 cannot fit into 1, but 3 can fit into 13 4 times. Multiply. 4 times 3 is 12. Subtract. Bring down. Oops, my smartboard's going real slow. Three goes into 19. 3 times what gets us really close to 19? Ooh, 3 times 6 is 18. Subtract. Bring down. How many groups of 3 can we make from 15? 5 groups. Multiply. 5 times 3 is 15. Subtract. There's nothing to bring down. That's when you know you're done. So that means the length of the sidewalk is 465, and it's just plain feet because they already gave us the area. This with square feet, but we just found the length of the side, so it's labeled just plain feet. Like this is just plain feet as well. Okay? So it's just plain feet because we're finding the length of the side. Okay, number 7, now let's find perimeter. Perimeter is the distance around a shape. So we need to do 8 plus 21, don't make that common mistake, plus 8 plus 21. You have to add the length of all the sides of the shape. It doesn't matter how you add. Some people do 21 plus 8 and then double it. Some people do 8 plus 8 and then 21 plus 21. And then put it together. As long as you add the length of all 4 sides, you're good. 21 is 42. Those are the 2 long sides. And 8 plus 8 is 16. Add it all together for a total of 58. And it's just going to be plain feet. Say plain perimeter. Plain perimeter. because you're just adding the lengths of things together. And the second one, 24 plus 16 plus 24 plus 16. So we're just adding the lengths together. I know that 24 plus 24, I could do that in my head, is 48, and it's okay if you can't. Always show your work if you need to. 16 plus 16, I know, is 32. So I have the two long sides plus the two short sides, giving me a total of 80. And it's just going to be plain centimeters, because notice in the picture, it's showing it as centimeters. Say plain perimeter. Perimeter is always labeled with just plain units because it's just adding the lengths of things. So we just did two perimeter problems. Now let's do a perimeter word problem. And this is slightly more complicated than the area word problem. Okay, so we have to work backward. The perimeter of a rectangle is 816 centimeters, and one of the dimensions is 152 centimeters. What's the length of the other dimension? So we're working backward. We know the total. They gave us the length of one side. What's the length of the other side? The first step, add what you know. And here's what we know. The length of this side is 152, and the length of that side is 152. So let's add what we know. 152 plus 152. 304. Now take our total minus that, and that'll give us what we have left to work with. Right? So let's take our total, which is 816, minus what we know, and that'll give us what we have left to work with. Okay? Gosh, that's an easy subtraction problem. So does that mean the length is 512? No, that means that the long side is 512. But I just need to know what the side is. So I now need, as my last step, to take 512 and cut it in half. So let's take 512, what we have left, and cut it in half. When you cut something in half, that's dividing by 2. 2 goes into 5 2 times. Multiply. 2 times 2 is 4. Subtract. Bring down. 2 goes into 11 5 times. Multiply. Subtract. Bring down. And 2 goes into 12 6 times. So that means that the length of each side is 256. Let's look at it and make sure it makes sense. 256 plus 256 is 512. Plus 152 plus 152 is 304. Altogether, it does equal 816. Now, it's just the length of the side. So I know 256 is my answer. I've got to look back up in the problem. I don't even remember if they talked about feet or inches or what. And if you look back up, you can tell that it's the centimeters. So it needs to be labeled cm, because it's just the length of the side. So it's just plain centimeters. All right, on to the last page. All right, number 9. 7 kids had a candy bar eating contest. Woohoo! They ate as many as they could in 3 minutes. Their results are shown below. So kid A, right, whoever that is, in 3 minutes ate 3 1/8 candy bars. I'm imagining those big Hershey bars. You know how they're split up into chunks already? So that kid ate 3 whole candy bars plus a little bit more. Kid B ate 2 whole candy bars plus a little more. Kid C, 2 whole candy bars plus another half a candy bar. Same with Kid D. Kid E ate exactly 3 candy bars. Kid F ate exactly 2 candy bars. And Kid G ate 3 1/2 candy bars. So we can see their results shown below. And there's a few things to do, so make sure you read the directions carefully. It says, complete the line plot below. Say, line plot. And you should have an X on your arms. And that reminds us that a line plot, each piece of data is shown with an X. Complete the line plot below. Be sure to finish labeling. Ooh, got to make sure we do this part. Be sure to finish labeling all of the marks along the line before you plot all the data points. So I can see that they started labeling it for us. At the bottom, I see 2, 2 1/8, and then there's a whole bunch of lines that we need to label. So let's go ahead and do that right now. And you're going to have to write really teeny tiny, okay? I can see that between 2 and 3, there are 8 jumps, which means each jump is going to be an eighth. So 2, 2 1/8, 2 2/8. Good. Go ahead and write that nice and small. 2 3/8 would come next. 2 4/8. What is 2 4/8 the same as? 2 1/2. That's right. 2 5/8. 2 6/8. I'm sure you're having to write quite small. 2 7/8. 2 8/8 is the same as 3. All right, let's keep labeling. After 3, if each line is an eighth, next would come 3 1/8. Very good. 3 2/8. 3 3/8. 3 4/8. What is 3 4/8 the same as? 3 1/2. That's right. 3 5/8. 3 6/8. 3 7/8. And 3 8/8 is the same thing as 4. Good. Okay, so we have all of them labeled. And now I'm going to put my data on the line plot. So I need to go back up to my table with kid A through kid G. Let's see. A, B, C, D, E, F, G. There are 7 kids, which means how many X's will we have? 7 X's, exactly. So kid A is at 3 1/8. Be really careful. I remember very vividly grading these tests last year. So many kids put the X's in the wrong place because they didn't make all of the denominators the same. They didn't make all the denominators into eighths. So I'll show you what kids did. 3 1/8. We're good because 8 is already in the denominator. So 3 1/8. There's 3 1/8. So put your first X there. And I think I'll check it off to make sure that I've done it. Letter B, 2 1/4. Kids would put it at like 2 4/8. They did like crazy things. We need to make that have a denominator of 8. If you double the top, you better double the bottom, and that will give us a denominator of 8. So before we do anything, let's write that 2 1/4, double the top and double the bottom. 2 1/4 is the same as 2 2/8. Now the denominator is an 8. Now I know exactly where it goes on the line plot. So 2 1/4 is 2 2/8, which is right here. Okay. Letters C and D are both 2 1/2. If we quadruple the bottom and quadruple the top, we know that 2 1/2, and you probably already know this, is 2 4/8. Because 4/8 is the same thing as a half, right? If you got a 4 out of 8 on a test or on a quiz, you got half. So 2 1/2 is 2 4/8. So I need an X here, 2 4/8, and I need another X for 2 4/8. So it's very important to make all of the denominators an 8, because then putting it on the line plot is much easier and I won't make a mistake, or I shouldn't make a mistake. Kid E is easy because it's right at 3, so let's put an X right at 3 candy bars. Kid F is exactly 2 candy bars. And the last one, 3 1/2. If I quadruple the numerator and quadruple the denominator, I know that 3 1/2 is the same thing as 3 4/8. So now I know I put it in the right spot. A lot of kids would put 3.5. They saw the 1, and they'd put it at 3 1/8. 3.5 is not 3 1/8. 3.5 is the same as 3 4/8. So making all of the denominators have the same will make it easier to put on the line plot. Okay? All right. 1, 2, 3, 4, 5, 6, 7 x's. We're good. Now we have some questions, and only if our x's are in the right spot will we get these problems correct. The first one says, what is the minimum number of candy bars? Say, minimum. The minimum is where the smallest piece of data is. What's the smallest amount of candy bars or the fewest amount of candy bars anybody ate in those 3 minutes? The smallest x is at, say it out loud, at 2. Yeah, so our minimum is 2. Maximum. What is our maximum? And don't you dare say 4. There's no data at 4. Nobody ate 4 candy bars. Where's our biggest piece of data? Where's our biggest piece of data? Say it out loud. 3 4/8, which I would accept. But how many people know that they would probably simplify it? Most people probably would simplify it, most mathematicians. So either 3 4/8 or 3.5 I would accept. It's the maximum. The difference between the max and the minimum is called the range. Home on the range. Where the max and the minimum play. Or it's the biggest number minus the smallest number in the group. In the group. So if we take our maximum minus our minimum, we will get the difference between the two. So our maximum is 3.5. Our minimum is 2. And if you subtract, what's a big old 3 minus a big old 2? A big old 1. And what's a half minus nothing? A half. So the difference between the two is 1.5. That means the kid that ate the most ate 1.5 candy bars more than the kid that ate the least. So they were really cruising during those 3 minutes. Mode, most, mode, most. What is the most popular number? And you can tell on your line plot because there should be x's stacked on top of each other, right? The most frequent, the most popular. Or you can think mode, mode. It's the number that occurs the most. What's our mode? Say it out loud. 2 4/8, which is the same as 2.5. Good. It's the most frequent number. And this last one, we're going to have to do an addition problem. It says, how many candy bars did the 3 kids who ate the most eat all together? When you see that word all together, do you think adding or subtracting? Adding, that's right. And we need to add the 3 best candy bar eaters, okay? So the 3 best candy bar eaters are those 3 kids, right? So I'm going to add those 3 numbers together. So I see this kid was at 3, this kid's at 3 1/8, and this kid's at 3 4/8. So I need to add those 3 numbers together. 3 plus 3 1/8 plus 3 4/8. So go ahead and write that down. 3 plus 3 1/8 plus 3 4/8. And I like that I have both fractions have an 8 in the denominator because when we're adding, we want the denominator to be the same. Do you remember saying earlier in the year, if the denominators are not the same? Exactly. Okay, so our adding should be pretty easy. What's a big old 3 plus a big old 3 plus a big old 3? 9. Good. And then what's 1/8 plus 4/8? 5/8. And you can't simplify that because 5 is a prime number. So 9 5/8 is our final answer. All right, here are the answers for page 1, page 2, page 3, and page 4. Be really conscious of what you did well on and what you didn't do well on. Those are the types of things you'll want to focus on. Okay? All right, kiddos, I will see you in class.